So guys, welcome to the first presentation in the smart lighting track. Good morning and good afternoon and good evening. So my name is Alan Silito. I'm looking after global key accounts here at Wirepas. The first presentation will be construction and mining lighting by COOLON, and I have the privilege to be joined by two gentlemen from COOLON, Andrew Orkin, Business Development Manager, and Adrian Moo, Head of Product Strategy. Just a couple of housekeeping rules for you. The presentation as a whole will end in about 25 minutes. So we'll spend the first 20 minutes or so with the presentation from COOLON. Then there'll be a Q&A session at the end. Please feel free to drop your questions into the chat. Any questions we can't address right now, we'll get back to you after the event. So without further ado, over to Andrew and Adrian.
Hey guys, this is Andrew speaking. Can you, if I flick one screen, can you see my next slide now?
Yes.
Okay, excellent. I'm Andrew from COOLON. We're a lighting manufacturer from Australia. I don't know if many of you know us, but we specialize in lights that are manufactured for purpose and they're made for mining. We basically make lights that are indestructible, and we do this for a reason. So we've been doing it for the last 12 years, probably even more now, and we operate out of 6 different countries, and we have hundreds of thousands of lights installed all over the world. And there's one reason why we pride ourselves on this, because mining is tough. I mean, in order for us to make a light that survived this kind of environment, took a lot of effort, and we evolved over many years. In our world, it's very different to any other world. Lights usually don't get cleaned or maintained. If they ever got cleaned, they kind of do it with a fire hose or a hammer. It's not a really simple procedure as you usually imagine with the lighting world. So the point I'm trying to make here is mining is actually a really tough world. If you wanted to make a product that survives in a mining environment, you first of all have to make it survive the environment itself. But why does a reliable light matter? So the picture you're seeing here, I'm hoping you're seeing it. You're looking at the mining dredger, and that machine is about $50 million. That machine has to operate around the clock, so 24 hours a day, and it does not stop. If anything was to happen on this machine or with this machine at night or any time of the day, the crew needs to get to it quickly and fix whatever the problems are. Just to give you an idea, if a mine site, a typical iron ore mine site in Australia would pump out 150 million tons per annum of iron ore, that converts to about, I can't remember the numbers exactly, 500,000 tons per day. And in 1 hour, that's around $3 million worth of revenue that's being lost. So if this machine, obviously this is simplified, but in a nutshell, I'm just trying to show you that the consequences of bad lighting can be quite drastic in this world. So if anything happens to this machine and they can't fix it, every hour is literally quite a lot of money and quite a lot of downtime. Furthermore, if anything happens that causes the bottleneck in production, so then every other department that stands after this and every other process has to catch up with production in order to catch up with the lost time. So why is there a need for lighting in the first place? Well, lighting is actually mandatory. So any Australian mine site has to operate according to Australian standards. The standards are pretty simple. There's a book of it. I'm not going to talk about standards and lighting specifically, but I just cover it. It's 40 lux on the conveyors, 160 lux in open areas. In case of emergency, they have to be battery backed. Some of the lights have to be battery backed. And they have to provide 90 minutes worth of lighting to a very low level, but it still needs to be achieved everywhere. There's very specific standards that you have to adhere to. And if anything was to happen to any person on site, and as a result of bad lighting, the mine could be looking at getting shut down due to negligence. But it's really unusual for anyone who's never dealt with mining, and you're probably thinking, how long does it take to change a light bulb? Well, in the pictures here, you can see that in order to even get to the light bulb, you'd have to probably travel around 30 to 40 minutes, climb a hell of a lot of stairs. You have to carry the light fittings with you. Usually the spare parts are located somewhere in the workshop, and the workshop could be, again, 20 or 30 minutes away. You have to get in the car. If you forget something, you have to jump back in the car and then go back to the workshop. Before you attempt to do anything, you have to do job safety analysis checklist, where you kind of going through all the things that you need to do and all the things that could go wrong. Usually this work is done by 2 people. You're in the middle of a desert, in the middle of nowhere, so these people are quite highly paid. So you have 2 very highly paid electricians attempting to change a light bulb, and it ends up costing an absolute fortune. As you can see from the pictures on the right, a lot of these lights are located extremely high, so you have to hire specialized equipment like 40-meter boom lift just to go up there to change a light bulb. You can't do that every day. You can't do this on a windy or rainy day, so it becomes a very limiting factor. Lighting becomes a very critical and important factor. So what are the things that could kill the lights? Usually, our lights have to battle nature. So these are, again, they're located in the desert. So you have huge sandstorms, you have dust storms, you have cyclones that can inundate the entire area. A lot of the lighting that is in the iron ore area in Pilbara is that's where they're getting iron ore from. So the earth is literally covered in iron, and it produces some magnificent lightning storms. Unfortunately, it's not very good for equipment. The second thing, and probably most dominant in our area, is vibration. All the lights getting absolutely destroyed by vibration because they're in business of moving ore and millions of tons of ore. So usually wherever the lights are located, it's next to some sort of equipment, and that equipment is vibrating because it's moving ore non-stop. So if the light was not made for that purpose, all the components simply snap off, fall down, and that's the end of the light. The other thing that we have to make our lights withstand is corrosion. So you're looking at some photos, the photo on the top and the bottom from the chamber underneath the sulfuric acid tanks. So the blue things in the photo actually sulfuric acid leaking down the walls. Naturally, it gets down the wires, it gets onto the lights, it eats away through everything. So we have to pick materials very carefully. Our lights get exposed to this horrendous environment all the time. You still hear me okay?
Perfect, thank you.
Excellent. Our lights have to withstand through time. So this is one of the biggest challenges. Usually we don't think about that much, but in these kind of environments, it's the dust and dirt that gets built up, and it clogs up every vent hole, so for those of you who manufacture lights, you'll understand the importance of the heatsink in the LEDs. So a heatsink gets clogged up, all the screws get submerged and absolutely caked in. That's not just dust. That's typically it's iron ore, and once it compacts up to a certain pressure, it actually forms a solid bond. You could not even get it off with a chisel. So we have to make lights maintainable, and we have to make them completely indestructible. Light versus stupidity, that's my personal favorite. We are not working with majority of super intelligent people out there. As you can imagine, on both mining and construction, there's a lot of very rough people, let's just put it this way. So as you can see in the picture in the middle, they wouldn't back out the lighting plant from the blast zone, and they get blasted with stones, and the explosion, they get run over all the time. As well as working night shifts is a very tough job. Naturally, if you've been working 12 hours at night, people get tired, so all sorts of things happen. We get all sorts of abuse. But now that we're getting into smart lighting, we are seeing a whole avenue of us being able to bring a whole lot of value to the mining customers through the network of smart lighting. I'm not going to talk specifically about smart lighting here because this is what you're all about, but lighting forms a natural ideal backbone because we are located up high, very clear view for communication. we are constantly powered, so we're not dealing with battery devices. We have a mains power on board at all times. And we are basically everywhere where there are people, and people are any accessible area where there are people. That's where the lighting is, and that forms probably the biggest network of nodes. And if there were smart nodes, that would be a biggest network of smart nodes on any one site. Now, a couple of weeks ago, I did a presentation on a specific product, a smart lighting product for construction. So I'm not going to go over it again because you could just watch that if you want. But today I wanted to talk about smart lighting for mining, because ultimately the two are very similar, but mining is a little bit harsher. So if you can comply here, you could natively almost work in construction, or vice versa. So we're proposing to make lighting meshes data backbone, and as you can see, lights are everywhere, very high density, and it becomes a very reliable network. A lot of these lights are emergency, so even if the power was to disappear, the light still has the power. I wanted to, since we're talking to Wirepas partners, and we're looking for many Wirepas partners to work with us so we can expand the ecosystem, I wanted to cover the world of mining, kind of give you an introduction of 101 into mining, because I think this is going to be the best value for you. And as you're watching this, just as you learn about mining, have a look if there's anything, if any of your products could be suitable in this world. So typically a mine site looks like this. It's a ginormous scar on the ground. You can see it from satellite. There's an open cut scar in the middle. Down the bottom, there's a little bit of a plant. There's quite a lot of them around Australia. We're very lucky that we're a mining country, but there are quite a lot of them around the world too. So you just don't know about them because they're located quite remotely. This is what it looks like on the ground. A lot of equipment, a very tough and harsh environment, and it operates non-stop. There's a lot of noise, there's a lot of dust, there's a lot of pollution, a lot of expensive labor, and a lot of very, sometimes unhappy people. So we propose that with our lighting in place, with the smart lighting in place, we could actually generate the mesh, and you could have your device that some of you produce could be operating anywhere along the site, and our lights will provide the natural path for these devices to join. So it all starts off with mining open pit. Typically, if it's an open pit mine, these guys are severely focused on productivity. So they're laser sharp focus on getting the hundreds of million tons per annum towards the target. So it all starts off with shovel digging dirt in the middle of the pit. That shovel is extremely timed to be most productive and to fill up the truck as quickly as possible. Then these trucks race around the circuit to empty the bucket and come back. Like I said, this operation runs around the clock. So there are specific areas that are illuminated and some areas that are not illuminated. The point is that they're very performance focused. Some of the mining is done underground. These areas, again, are fairly difficult to work with. They're full of water, they're full of dust. There is sometimes a lot of traffic. In some areas, there's a lot of traffic. In some areas, there's little traffic, very limited power. Everything is kind of in the tunnels, a lot of radio reflections. So it's a challenge and a half, and you definitely need as many nodes as you can in order to make this work. Sometimes they dig out overburden or a waste ground with equipment like this. They're absolutely ginormous shovels called draglines. There's challenges with these things of their own. They're extremely big and extremely expensive to keep not running. So they need to be operating as much as possible with very little downtime. You can't exactly bring this thing to a workshop to fix something, so the workshop has to come to it. It's kind of like a building on feet. And these things walk instead of crawl. Dredging and stockpiling. So every mine site has, most mine sites have these kind of things. They stockpile the finished iron ore. Again, a lot of vibrations, a lot of conveyors, a lot of movement. They operate on rails. They have very limited movement. And if anything needs to be fixed, again, you have to come to it with all the tools and everything you need. or processing plants. This is the core of the operation. So once the good stuff has been dug up, it gets sent to these crushers and washers and extractors, and this is where most of the chemical and production happens. Naturally, there's a lot of equipment, a lot of potential for our sensing partners, anyone who's making any kind of sensing nodes. I'm sure there's going to be a lot of equipment that needs attention here. Again, any one of these equipments becomes extremely vital for operation. It could become a bottleneck if it's broken. Conveyors, most of the large mine sites are just covered in conveyors. This is how you move millions of tons of ore from one point to another. And these things need to be not only illuminated, they need to be well maintained. And every roller could spell a disaster. And there's tens of thousands of rollers. Conveyors sometimes go into tunnels. These are confined spaces. On a meter to your left is a wall, a meter to your right is a moving roller with a bulk of dirt. You get stuck, naturally you will lose a limb or potentially die. So this is a very dangerous environment. At the end of all of this, everything gets loaded onto a train, and then the trains go anywhere from 100 kilometers to typically 500, 600, 700 kilometers to port. And this is what the ports look like. Ultimately, the ore arrives at the end of the wharf, where it's deep enough for the ship to come up the wharf, and it gets loaded onto the ship. So what we're proposing here is, naturally, we have the most reliable light that we have been we've been using for well over a decade. There's so many of them out there. And once these lights are smart, we are in the process of making these lights smart now. And we're starting off with construction. We are already moving into mining, which is our home. And we are proposing to work with ecosystem partners. So we're looking for other partners to expand our value on and build up the network of environmental sensors, machine condition monitoring, like I just explained. There's many locations where these things could be useful. There's many locations that need to have fire equipment monitoring. Again, fire is a big issue in these places, so we do definitely need to keep track on them. Asset tags, personnel monitoring, naturally, they would want to know where the people are. Digital signage and all sorts of expansions. So anyone who can see any kind of expansions into the mining world, we definitely love to speak to.